Hey, I thought I'd, before I give you some notes about the beginning of this unit 2 here, I'd go ahead and collect some data, just like you're going to do. So you're going to start with this video here. You probably already did this. You should have already done this. And then at some point you figured out how to click on this and get this little measuring device, which you can move around, which is nice. And then you can play the video. Where's the little code? There he is. And wait for the little car, and you can go back a frame at a time, and you can start timing the car. Now, you could have this. You were maybe tempted to have the car start right at 0 position, but it doesn't have to. So I'm going to move mine just a little bit just to show you what it looks like if it's different than that. So let's say I started mine right here, and that's at 50 centimeters. I'm going to reset my time like that. That's how you started at 0. And we do these little pivot things. And then we're going to go one frame at a time. Now I got my data collection thing ready to go here. So this column name is going to be time. The units will be seconds, and the variable name, we'll call that t. In this column, we're going to do position. Position is like location. It doesn't tell you anything about whether something's moving or not. It just tells you where it is. That's the difference between position and distance. Distance implies that something went from somewhere to somewhere else, whereas position is just like, I don't know, it's just, this is where it is right now at this time. So position units are going to be centimeters, variable. Well, I could use different things. I'm going to use, because we're going to think of this as being like a number line, and it's a number line that goes across in the horizontal direction. And according to your math training, that is something that we usually call X. So I'm going to call this X for position. If you prefer to call it like P or POS for a position, that's fine. All right, so my first point I have already at time 0. This thing's at 50. Okay. Good. Now, let's go. So this is going pretty slow, so I don't think I need to do like every frame. I got to click like a whole bunch of frames here and let it get out too. Let's say I do I'll do every 10th of it, every 1 second. Let's do every 1 second. So it looks like right here it's at, let's see, if that was 50, 60, 70, 81, maybe 82. Let's say 81. So at time 1 second, we're at position 81. And I'm going to do 2 and then 3. Let's do every second. And that'll probably be enough for me right here. And then, so let's see, where are we going to be at? Two seconds. We are at position 110. Oh, let's see, 118. Looks like. Best as I can guess, 118. And then get up to 3 seconds. Did you know that I have a box of these exact cars? If you were here, we'd be playing with these things in person, which would be more fun. 152. These 10s or 5s? These are 10s. 152. And let's see, last one, get this timer up to 4 seconds. If you did times that were closer together, that's fine. You just have more data. Let's see, this is 150, 60, 70, 80, 88, let's say. 188. So how do I make it graph? My graph title should be position versus time. Why is it not letting me do anything there? Oh, I see. It wants me to do this first. So I want position on this axis. And I don't want this. That's just some statistics stuff. And time here. There we go. And when I go up to here, I would like to include, I always like to include the origin if we can. That's that. Looks nice and straight. And I'm going to go to curve fits. And we would like to have this line, it looks like it definitely does not go through the origin. So definitely we want a regular line. We don't want to force it through the origin. If we did, I'm not even going to show you that because it's going to be so ugly. This is nice. Oh boy, that's pretty. And there's my stuff here. And I'm just going to jot down because I don't know if it's going to tell me or not. I'm going to, before I click lock answers and continue, I'm going to write down what the A and the B are. The A and the B are my slope and my intercept. So maybe instead of that, I'll write down slope is 34.7. I'll think about the units in a second. And the intercept is 48.4. All right. So that looks pretty good. And oh, look at this. It even put units in there for us. So let me copy those down too. So it's centimeters over seconds for the slope. And the intercept has units of centimeters. Notice I didn't, this little plus or minus thing, that just has to do with like a statistical analysis of how far the points are away from the line and like some kind of error stuff. It's interesting. It's stuff you're going to study if you ever take stats. It's not something that we are interested in. We're just looking at this front number here. And this RMSE, that's also a measurement of how good the line is. So that's good. So we locked up that section. Notice you can click on the graph to select which column, select distance axis. So we already did that. What are the units for the vertical axis? The vertical axis has units of centimeters and seconds for the horizontal axis. Linear option. What are the units for the slope? Centimeters over seconds. And for here, what do they want? The equation will be, so here I want to have x, which is my position, equals, my slope was 34.7. Is this a little like enter formula? No, I guess I'm not going to use that. 34.7 centimeters over, I'm going to put the 1 on the bottom, 1 second. 34.7 centimeters over 1 second times time. This is my y equals mx plus b, but I'm not using these letters. I'm using the ones that actually represent what I got here. Why is this an x here? Because that's what I call the position. Equals, here's my slope. Here's my horizontal variable name, time, plus the intercept is, what was it, 48.4. 48.4 centimeters. All right. Is there a y-intercept? Yes. Explain what the significance of it is. Yes. the significance of the y-intercept is the position, it's how much y you have, the position of the car when you have no, when your horizontal axis is at 0, when time is 0. In other words, it's starting position. Now, if you're looking at that, going and thinking to yourself, "Hey, McGrath, was not the starting position of my car. My car started at 0." Well, that's fine. You just put your number line down in a different place. It doesn't. I mean, the world that we like to do physics about doesn't come with number lines and measuring tools attached. We got to come up with those. So I might put my number line down in a different place, and we can compare and say, "Oh, my origin is 50 centimeters to the right of your origin." You know, we can come up with things like that, statements like that to make ours.
3503, then tank, please call extension 3503.
Sorry about that. To make our different models reconcilable. But for now, whatever yours looks like, that's fine. Whatever mine looks like, that's fine. What should be the same is the slope, because what's the meaning of the slope? I feel like, shouldn't I ask that? I guess they told you that here. Slope tells us how many vertical axis units. The blah changes for every additional one of these. So here, we would say the meaning of the slope is for each 1 second, or that sounds awkward. How about for every second that passes, the car moves about 34.7 centimeters. I'm going to say in the positive direction. Important. That's what we're talking about for the meaning of the slope. So if you're wondering what, I got the answers. I'll leave you with that part here. If you're wondering what does this have to do with all the stuff we did in Unit 1, I hope that you can see that this is just another example of a line, a mathematical model that we came up with that has some meaning in the physical world here. In this case, what this little car is doing. So there you go. That's the first part of your video. I'm going to give you a little brief notes video. Please take those notes so you have them and you can refer to them throughout this unit. Let's see. Let's just do this real quick. So use how much time it would take for the car to travel 4.3 meters. Now, I'm not crazy about the way that this was asked. So how much time it would take for the car from the video to travel that far. So in my equation, since mine started at 48.4 centimeters, it actually started at 50, I would have to figure out here, my model, how much time it would take for the car to travel 4.3 meters. If it's going to travel 4.3 meters, that means it's going to be at 4.8 meters because it already started, it had a head start at 50 centimeters. So that would be at x equals 4.8 meters. So what would that look like if I did the math? Well, that's the position. So I'd have to do 4.8. I'd have to plug that in. I'm plugging things into my equation right here. So there's the 4.8 goes there. I'm going to not write down units when I start doing algebra. I think it's too confusing to have all the units in there. Some physics teachers just disagree with that, but that's the way I'm going to roll. So just 34.7. I'm just taking the number without the units here because I'm doing math. And then times time. That's what I'm trying to figure out here. Plus 48.4. Except there's a problem here. They told me this in meters. And now I've got this in centimeters per second. And this is centimeters. So this is no good. I have to change this. Everything has to be the same units. Hey, this is more stuff that you did in Unit 1, right? So 4.8 meters is 480 centimeters. So I converted everything to that. And then a little bit of math, little two-step equation. If you can't successfully solve an algebra equation like that at this point in your mathematical career, then boy, we sure have wasted a lot of time, haven't we? And I apologize on behalf of the educational system of Rockbridge County, Virginia, United States of America. Oops, I messed it up. Huh, that's funny. So 480, I'm subtracting the 48.4 over to the other side. I'm going to divide by 34.7. And I got about 12.4 seconds. Oh, that's that. All right.